Good evening, everyone. I welcome you all in a Sapience education. So today I'm going to discuss about the topic Carnot's theorem. So what actually Carnot's theorem states? We need to understand that Carnot engine is the only reversible engine operating between the two temperature. Okay. Otherwise, it is not possible to make any other engine. And you also know that the Carnot theorem is a hypothetical Carnot engine is a hypothetical engine. Actually it does not exist. Okay, but for ideal condition we have to take that it as a Carnot engine. Okay, now when engine get reversed, so what will happen? Let us see here. This is high temperature, this is low temperature, and there is a heat engine operating between these two high and lower temperature. So what happen? Heat will get absorbed from high temperature and it will get rejected to the lower one. So net work done will happen, that is known as work W. Now when engine get reverse, see, when engine get reverse, then what will happen? See, when engine get reversed, then what will happen? It will act as a refrigerator. Why a refrigerator? Because in earlier case, heat engine absorbs heat and reject the heat. But as soon as the engine gets reversed, so what will happen? Heat will be absorbed from the lower temperature and it will be rejected at a higher temperature. It will act as a refrigerator or AC. So that's why it is known as reversible refrigeration engine. Okay, the heat engine, when you reverse heat engine, that reverse the cycle. For example, here Q is supplied, here Q is rejected, and here Q is rejected, here it is a Q is applied. Okay, so it get reversed. So when it get reversed, so the engine has been changed to refrigeration. Okay, so QS is the heat supplied, QA is the heat absorbed, and QR is the heat rejected. Okay, now this theorem states that, first of all we need to understand what this theorem want to say. This theorem states that no engine has more efficiency than Carnot engine. It is not possible to create any engine which has a efficiency more than Carnot engine. Let us consider two engine working on same thermal reservoir. Okay, this is a TH and T low, and both engines are working at a same. Both engine are working for a same thermal reservoir. Okay, same thermal reservoir, and I is irreversible engine and R is your reversible engine. So we have taken two type of engine. One is your irreversible engine and one is a reversible engine. Okay, so in irreversible engine, heat has been absorbed by irreversible engine as a Q1, and work done W dash is the work output by the irreversible engine, and after that heat rejected is equal to Q1 minus W dash. Now for reversible engine, we set up all this thing in such a way that the reversible engine will reject heat as a Q1. Here it is taking Q1 as a heat absorption. Here it is rejecting a heat of the Q1 only. Okay, and Q2 is the heat absorbed by the reversible heat engine. So what will be the work input? So work input will be W is equal to Q1 minus Q2. Okay, W and Q2 both when combined to give Q1, so that's why work done will be equal to Q1 minus Q2. I hope you have understood this now. Till now you have no problem at all. Okay, now as two engines are working between the same source and sink, see here it is a high temperature, lower temperature, and both are working on them between the same engine. Now couple both the engine in such a way that I will act as a heat engine and R will act as a refrigerator. Just now we have discussed. See here, I will act as a heat engine, that's why it is giving output as a work, and R reversible engine act as a refrigerator. Okay, so that's why there is a work input in this. Okay, let us assume that efficiency of irreversible engine is more than reversible. Let us assume, okay, it is not true or false, we will see it later, but we need to assume that irreversible engine has a more efficiency than reversible engine. So the efficiency of a reversible engine is greater than the reversible engine. We have just assumed, okay, it is we don't know what will happen later, but we should assume this. Since here, tell me, if efficiency of irreversible engine is greater than reversible, so if reversible engine would have worked as heat engine. Now tell me, if reversible heat engine would have worked as heat engine, so what will happen? So it will act as a heat engine, then the work output by the reversible engine will be less than work output by the irreversible engine. Why so? Because the efficiency of the irreversible engine is more than reversible engine, we have assumed. That's why we are telling that W is less than W1. Now for a particular heat, see here, for a particular heat, as reversible acting are engine acting like a refrigerator. So Q2 will be equal to what? Q1 minus QW. See here. See, Q1 is equal to W plus Q2. So from here Q2 will be equal to W minus Q1. So Q1 minus W now is greater than Q1 minus W dash. Why? Why so? Because Q1 minus W is greater than Q1 minus W dash, because W is less than W dash. That's the reason. That's the reason, indirect reason. Okay. So that's why Q1W, that is this one. Q1W, Q2 is your Q1 minus W is the Q2 one, and Q1 minus W dash. So which is more? So definitely Q1 minus W is more than Q1 minus W. Okay, Q1 minus W dash. Now if we make a irreversible engine and R as a single system, so we will consider it as a single system from lower temperature. So what you will consider? See, if I will combine, try to understand from here. Let us understand this irreversible engine and reversible engine. If I will combine this, so what will happen? Heat is, now I am considering this as a single engine only, having a two type of engine, irreversible and reversible, in same entity, like it's the same inside. So what happened here? Q1 is coming and Q1 is going outside, means net Q1 will be 0. So the Q1 minus Q1, this will be equal to 0. So no heat is either absorbed or rejected in the TH. So this engine has no issue at all. Now see here, our when we combine this both, so what will happen? Q1 minus W dash minus Q1 minus W. So what will happen? Q1 will get cancelled out. So W minus W dash, or W dash minus W is the heat which is being supplied to this both system, and there is an output work W dash minus W. So now we have seen that, see here, heat absorbed from lower temperature is Q1 minus W minus Q1 minus W dash. Why so? Because see here, heat absorbed, and this is positive and this is your negative, because heat is being rejected. That's why we have combined this. So we have got W dash minus W from the cold temperature. So what you have seen there, so here we can see that heat is being absorbed by the system and there is a rejection of the work done without using another temperature. It means that it is clearly against the Kelvin's Planck's statement, whatever we have studied in second law of thermodynamics. So due to this verification, we can conclude that our assumption was wrong. Our assumption was wrong. Assumption was wrong. Okay. So as our assumption was wrong, so that's why efficiency of reversible engine is greater than efficiency of irreversible engine. Now there is another statement which is known as second statement of the Carnot theorem. It states that Carnot engine is independent of the working substance. Yeah, it does not, it depends upon the working substance. So let us consider, we have already derived the efficiency of the Carnot engine as 1 minus T1 by T2. Now this formula is derived from the ideal gas, still no dependency of the working substance. See, is there anything R like or gas property? No, only it is just outer, that is high temperature as well as low temperature, that is source temperature as well as sink temperature. It depends upon source and sink temperature, but it does not depend upon the characteristics of the any gas. So the Carnot engine only depends upon the source as well as sink temperature. So for a Carnot engine, Q1 by Q2 is equal to T1 by T2. So this thing you need to understand. I hope you have understood this Carnot theorem properly. Thank you for attending my class.